Welcome to the Pre-Calculus Notes for Essential Skill F2, Determining Trigonometric Equations. In section F1, we learned how to graph trigonometric equations. We're going to go backwards in this section. We're going to start with a graph, or with features of a graph, and determine an equation that would fit that graph. We'll start with this example. We're going to determine the vertical parameters first, the vertical shift and the vertical compression, or expansion. We start by finding the maximum and the minimum. We can just do that visually. The top of the curve is the maximum, and it's at 1, 2, 3, 4, 5, 6, 7. That's the max. And the minimum, we just look across. We're at 1, 2, negative 3. That's our minimum. Since the vertical shift parameter is the same as the location of the midline, we start by finding the midline. The midline is exactly halfway between the minimum and the maximum. What we do to find that is simply average them. We'll add that to the graph. We can verify visually that it looks like it's going right down the middle of the wave, and it is. The next piece we're going to look at is the amplitude, which is going to be related to the vertical stretch factor. That's going to get us the A parameter. Remember that the amplitude is the height above the midline. To find that, we'll simply subtract the midline value from the maximum. Amplitude is always positive. To find A is a little bit more complicated. It depends on whether we're going to have a vertical flip or not, and that depends on identifying where the beginning of the wave is. We'll look at that on the next page. To figure out the horizontal shift and the horizontal stretch, we need to know where the cycle starts. To do this, we need to be familiar with what a sine wave and a cosine wave look like. I'm going to start with a cosine wave. Cosine waves are pretty easy to spot because their first anchor point is always at the top. Remember that cosine of 0 is 1, so at the beginning, it's at the top of its wave. So this is a cycle of cosine. We go all the way back up to where we started. Here is the beginning of our wave. Here's the end of our wave. That is one period of cosine. We're going to identify where that period starts and where that period ends. So it starts at x equals 5, ends at x equals 13. The phase shift is simply the beginning of where the curve starts. This is a cosine curve that's been shifted over 5 units. Normally cosine would start at x equals 0. Now it's starting at x equals 5. Therefore, all this depends on is the beginning of our highlighted cycle. If it seems a bit arbitrary to say it's the beginning of the cycle we chose, that's valid. We could have chosen a different cycle, in which case we would have a different starting point. That means that there can be multiple answers, and that's okay. We're going to look at a second answer on the next page. To find the period, this is the same as we found it before. It's simply the last anchor point minus the first anchor point. In this case, our last anchor point was at 13, and our first was at 5. So our period is 8. Notice that's not the same as our compression factor. To find the actual B parameter, we start by saying, what would a normal period have been? Well, 2 pi. That's the period of sine and cosine, because that's how long it takes for the functions to start repeating themselves. Now, we want to know how you would compress that to get a period of 8. So, this period times b gives us 2 pi, which means that our b parameter is going to be 2 pi over 8, or pi over 4. This is a nice shortcut to find b. It's 2 pi divided by the new period. That's worth remembering. It's a nice shortcut. At the end, we put this all together. Let's go back and review what we found. The amplitude was 5. Now we can revisit the question of how to find A. Which cycle did we focus on? We know that the amplitude is equal to the absolute value of A. If the amplitude is 5, then that means A is either 5 or negative 5. The question you ask is the highlighted cycle flipped? Do we have a vertical flip? Well, we chose a cosine curve that is right side up. Our first value was at the top of the wave, just like an unmodified cosine graph. If it's not flipped, then A will be positive. If it had been flipped, A would be negative. So A was 5, D was 2. Let's transfer those numbers. What was B? Pi over 4. What was C? C equals 5. And now it's simply A. What kind of cycle did we highlight? That's a cosine cycle. Cosines start at the top. B. Parentheses. Parentheses are critical. That matches our standard form. And there's our equation. Now, I said that there were multiple ways that you could come up with an equation. So here is another way. We find another type of cycle to highlight. This one's a little bit harder to see until you draw in the midline. So I'll put it where we found it. It was at 2. We know this. And remember that a sine graph starts right on the median line. The sine of 0 is 0, meaning that sine starts in the middle. So this is going to be one cycle of sine. I'll highlight that. Now we come up with the parameters. The amplitude is the height. 1, 2, 3, 4, 5. It's also the maximum minus the minimum. Remember that the maximum was 7. Since our sine curve is right side up, not upside down, A is going to be positive 5. for the period. We're going to find the x coordinates of the starting point and the ending point. 1, 2, 3. So the period is 8. That's the width of one cycle, the raw width. To find b, remember it's 2 pi over the period, which simplifies to pi over 4. Notice that it's the same as when we used cosine. One period should always be the same width, regardless of which cycle you choose to highlight. Our phase shift, we start at 3. C is just 3. The midline is at y equals 2 again, and so d equals 2. Here's our answer. We pull these numbers, 5, sine, because we drew a sine graph, we highlighted a cycle of sine, pi over 4 times. So what changed between this equation and our original answer? The function and the phase shift. And that's it. Everything else stayed the same. So this does lead to multiple possible answers. Let's look at another example. The first and most important thing is to decide which cycle you're going to use. You have options. I'm going to highlight these in turn. You probably don't want to copy these because that'll get messy. Just pick one. We'll just pick one that we like at the end. You can actually find right side up cosine in this wave, a right side up sine, or an upside down cosine, or an upside down sine. They're all there. Let me go through them. Here's a right side up cosine. I feel like that's one of the easier ones to identify, and so I'm probably going to do this at the end. But let me show you the others. Here's a right side up sine. We could start the cycle at x equals 5, and that would work. Here's what an inverted cosine looks like. Notice our first point of the cycle is down instead of up. That's because we did a vertical flip. Since cosine of 0 is 1, the negative cosine of 0 would be negative 1. We're down first. And this is a complete cycle because this is where it repeats itself at the next valley. This is valid, we just need to remember to make a negative. Finally, this is what an inverted sine looks like. Normally, on a sine graph, we start at the midline on the way up. Here, we're starting at the midline on the way down. Inverted sine. All 4 of these are valid, but I think the one I'm going to do, just for the sake of example, is the inverted cosine, just so you can see how that works. I'm going to fill this in so that I'll have it to refer to later. And now I'm going to identify the dimensions. Here's our maximum. Here's our minimum. So our minimum is at 2. Our maximum is at 3, 4, 5. The first thing we can determine is the midline. We're just going to average 2 and 12. There's our midline. I'll go ahead and plot that. Next, the amplitude is maximum minus midline. So we'll find the maximum, and that is difference between maximum and median. Here's where we need to be careful. We chose negative cosine. So A is going to be a negative value. Notice, amplitude is always positive. A might be negative depending on the wave we chose. Now for the horizontal piece. Here are the endpoints of the cycle. So our period is going to be the difference. We went from x equals 3 to x equals 11. So that is the period. Remember that b is 2 pi over the period. Once again, we get pi over 4. That won't always be the case. Kind of a coincidence that that happened with these examples. The phase shift is the beginning of the cycle of the function we chose. The phase shift has to be correct for the function we chose. We started at x equals 3, and that's just our value of c. Now we have all the parameters we need. We put it together using all this information. And we're done. Our final example for the video is one for you to try. Take a moment, pause the video, and work through this, and then I'll put my solution up. Here's my solution. And here's the answer that you should have gotten. I did say that there were multiple functions that you could choose. However, on this one I kind of backed you into a corner. There is another option. You technically could use a negative sine curve starting back here, but there are no other complete cycles that are on the grid that I gave you. So you're kind of limited by that. If you did choose to do a negative sine, your starting point of the cycle would be at x equals -2. Here's what the answer would be. Notice that it only changes the beginning of where the cycle is. It still has the same width, so the same horizontal compression, and it certainly still has the same height and vertical shift. Thank you for watching. We'll do the rest of the notes in class tomorrow.